Okay, guys, so we will continue solving this problem. So for the person who was asking about the location of the centroid, it's fine. Okay, so I will continue. Once we find the point of application of FV, okay, we still need to find the point of application of the weight of the gate, because we said that what are the forces acting on the gate? We have the force F, the weight of the gate, the horizontal and the vertical force. Now, in order to know the point of application of the weight of the gate, it's simple, because here we have a quarter of circle. And if you go to formulas of centroid, for a quarter of circle, they told you that the distance between the point of application of the weight and the vertical, so this distance from here to here, is 2r over pi. Okay, so this is characteristic of a line. You have the centroid of lines. If you go to centroid of lines, you can find that for a quarter of circle, the distance from the centroid to this vertical direction is 2 times r over pi. Okay, so you get it. You can get it from any list on centroid of lines. So until now, we know everything. We know all forces. We know all point of applications. Okay. Now we can move to the final step. The final step is we want to ensure equilibrium. To ensure equilibrium, we do sum of moments about point B should be 0. Why we selected point B? Because you know the hinge will represent two reactions, By and Bx. Okay. And in equilibrium, in 2D equilibrium, you can solve for 3 unknowns, if you remember from statics. You can find Bx, By, and you can find your force F. Okay? So here, because we are not interested... Yes?
مش ال distance 4r over 3 pi
4r over 3 pi هي السنترويد for the quarter of circle. Okay? Look, it's here. This is 4r over 3 pi. It's the centroid of a quarter of circle. But here the weight you want is not for the area, you want the weight for the line. This is the weight of the gate, and your gate is only this, the arc of circle. Okay? So you need to find the location of centroid of the arc of circle, which is at 2r over pi. While here, when we got the centroid, for the centroid here, in this, for the centroid of the quarter circle area, we used 4r over pi, over 3 pi. Okay?
Yes.
Okay. So now we can move to find F. Because as we said, we don't need Bx, By. So we need to choose sum of moment about point B. Because when we do sum of moment about point B, Bx, By will cancel out since they pass by point B. Okay? So when we do sum of moment about B is equal to 0, we can find F. Okay? So let us choose a positive direction. If we choose the clockwise direction as positive, so select the clockwise direction as positive. Okay, so what do we have? We have F, the distance of F from point B is, this is the distance of F. If we put it here, it's from here to here. This is equal to 8, because this is the line of action of F. So this distance is 8. So we have F times 8. We have now for the weight of the gate, we need to find this distance. Okay, the distance from the way to point B, which will be equal to 8 minus 2r over 4. Okay, So for the weight, it's also rotating in the clockwise direction. So it's plus. So plus the weight of the gate, W, times 8 minus 2R over pi. Okay. And now what we still have the moments of the vertical and the horizontal force. And as you can see from the figure, they tend to rotate the gate in the counterclockwise direction. So it's minus. So I will put minus FV. Now for FV, we have already found XC. Okay. So it's FV times X of C, which was already calculated. And for F horizontal, the distance from B is 2.67. So minus FH times 2.67 equals to 0. The only unknown in this equation is F. You get the value of F. Okay? So in this problem, we have solved what is the value of F needed to maintain the gate into equilibrium. Any question before we move to another problem? Okay. Now for problem 8, determine the total hydrostatic force on curved surface AB in the figure and its line of action. Neglect atmospheric pressure and assume unit width into the paper. So here it's more simple, because here you have just the surface and you have the fluid above the surface. Okay, so here you can directly use the course material given. Is that if I have a curved surface, I can decompose the action of water on the surface by 2. I have the vertical force and the horizontal force. Okay, now how to find these forces? So this is, let's say, a vertical, and this is F horizontal. First, we go back to, it's like the previous problem. Okay, for F horizontal, as we said, it's equal to the force acting on the projected area. So here, when you project, you will get a rectangle. Okay, so this is FH is very simple. Is the force acting on the projected area. This is the projected area. It's a rectangle. So, and since you have a free surface, you can directly say that the point of application of FH is at h over 3 from the bottom. So directly I can say that here, this distance from here to here is, so this distance is h over 3. In this problem, the depth of water is 1 meter. So this height here is 1 over 3 meters. Okay. Now, in order to find the magnitude of FH, it's also simple. We know that FH is equal to the area of the projected area times the pressure at the centroid of this area. Okay. What is the pressure at the centroid of this area? This is the centroid. It is located at a depth of h over 2. Okay. So the distance here is 0.5 meters. So this is 0.5. So now we can say that F horizontal is equal to, now what is the projected area? It's 1, which is the height times the width. They said assume unit width, so the area is 1 times the pressure. The pressure is gamma of the fluid, okay, times the depth of the center, because we want pressure at C. The depth is 0.5, so it's gamma times 0.5. Okay, and we found F horizontal. Now the second step is F vertical. If we go back to the course material, the definition of the vertical force on a curved surface is equal to the weight of fluid above it. Okay? So here, what is the part of fluid above the surface? You have this part. So if I draw it here, you have a volume of water above your surface. This is the volume of water above the surface. Okay? So by definition, FV is equal to the weight of this volume. And to find the weight, so we should say that FV is equal to weight of fluid above the surface it is equal to gamma times the volume. Okay, now how to find the volume of this part? First, you have unit width. Okay, so it's equal to gamma times this area of water above surface. Okay, this area I will call it here, this is area of water. Okay, and I want to find what is the area of water. This is the only little complex thing in this problem. Okay, because it's not a known geometry, so to find the area I should do integration. Okay, now let us look at what is given. What is given for us is the equation of the curve. This curve is of equation z equal to x cubed. Okay, so in order to find the total area, I should do integration and divide it into small parts and then integrate. If I consider a very small part of this area, the width will be dx. Okay, so this is dx, and the height of this rectangle, this height is equal to 1 minus what? Minus this part. Okay, what is this part? This is my function x cubed. So I can say that the height of interest here is 1 minus x cubed. Okay, and now I can write that elementary area dA is equal to 1 minus x cubed times dx. Okay, and now to find the total area, all I have to do is to integrate, and I will integrate from this position here, which corresponds to x equals 0, to this position, which corresponds to x equal 1. This is why, as you can see in this formula, f vertical is equal to gamma times the width times integral between 0 and 1 of 1 minus x cubed dx. Okay, it's a very simple integration. It will give you x minus x4 over 4 between 0 and 1. If you replace, you get 3 over 4. Okay, so f vertical is 3 over 4 gamma b, and you can calculate. Now, I found.
Doctor, can you please repeat the concept على الاريا كيف طلعناها؟
Yes, sure. If you have a curve of any shape, okay, it's not a known shape, it's not a circle, it's not a parabola of second degree to directly use a simple formula. It's a curve of a certain coefficient. So here it's z equal to x cubed. Okay, and you want to find the area formed here, this part. Okay, what you can do, you can divide your area into small, very small parts. Okay, and then you do integration to find the total area. Now, what is the elementary area we will consider? If you take any small element, okay, since you are dividing your area into parts along this direction, then your width is along x, and you are taking a very small element. This is why the width here, this part is called dx, because it's an elementary length in x direction. This is dx. Okay, now For an area, you need to find the weight and the height. What will be the height here? The height is the distance from this point to this one, okay? What will be this distance? You know that the total height here is 1 meter. And you know that the distance from the x-axis to the curve is x cubed, because this function z is equal to x cubed. So for any position x, this distance corresponds to x cubed. Okay? So this is x cubed, and the total distance is 1. So you can say that the part I am interested in, which is the height of the elementary rectangle here, is equal to 1 minus x cubed. Okay? Now, you will say that a small area, dA, is equal to the small width, which is dx, times the height, which is 1 minus x cubed. Okay? Now, if you want to find the total area, what should you do? Because you have infinity of elements, you should do integration. Okay? So the total area will be integral. This is the total area, as you can see it here. It's integral from 0 to 1 of dA. This is the elementary area dA, which is 1 minus x cubed times dx. Did I answer your question?
Yes, doctor, thank you.
Okay. Now, we still need to know what is the point of application of F vertical. Okay? Who will give me an idea how we find the point of application of F vertical? From the course yes.
لا ما خصهم summation of moment.
هي مثل summation of moment. Look, مش نحن قلنا F vertical represents the weight of the fluid above the surface. Okay? So it should pass by what? Weight. If you have a weight, it will pass by what?
Center of gravity.
Very good. The weight passed by the center of gravity of the volume. Okay? And here, the vertical force should pass by the center of gravity, which will be here equal to the centroid. You know why? Because you have one fluid. When you have one homogeneous fluid, the position of the center of gravity will be the same as the position of the centroid. Okay? So always the vertical force should pass by, it's equivalent to the weight of the fluid here above the surface, and the weight should pass by the center of gravity. But because it's a homogeneous fluid, the center of gravity is the same as the centroid of the volume. And to find the centroid of the volume location, I consider this is my volume. I have unit width, okay? Concerning the width, I don't have a problem because I have symmetry, so it will be at the middle. Now, what I need to find is the x position of the centroid. Why? Because F is vertical, okay? So I need to determine x of centroid. I need to find this distance. Can you please mute your microphones? This is x of the centroid. And in order to find x of the centroid, I will go back to the formula we have used in the previous problem, okay? In the previous problem, we said that x total, which is x of the center of gravity, centroid, times total area is equal to sum of xi ai, okay? But here, because it's not a finite summation, you have infinite elements. Instead of summation, what do you put? You put integration. So it's integral, okay, xi times d. What I mean here by d, it's elementary area, dai, okay? So here, if you want to see how we write it,
دكتور يعني بس يكون عندنا فيجر مثل هونيك فري بادي دايجرام نعملها بسميشن اوف مومنت، بس يكون عندنا كيرف نعمل انتجريشن دائما، صح؟
Look, don't say don't remember things as they are, because in each problem you should act to the situation, okay? But you should understand the concept. When you have here infinity of elements to do summation, you should do integration. In the other problem, you had large surfaces. So I have a square and I subtract from it a quarter of circle. There are two big parts. Then you do sum xiai. Or you do sum of moment because it's equivalent. Okay, because I told you the force is proportional to the area. So if you multiply A by, in the previous problem, when you multiplied A by gamma and width, you get a moment. Okay? So understand the concept, and for each problem, use the corresponding concept. So here, this equation is also equivalent to moments, because as I told you, when you multiply the area by gamma and the width, you get a force. You get a force, and you are multiplying a force by a distance, so you get a moment. So it's equivalent. The only difference is that in the other problem, you have finite number of elements. This is why you use sum, while here, because you have infinite elements, you use integration. Okay? So here, x bar is integral x dA over integral dA. What is integral dA? This is the total area. Okay? So it's equivalent to the formula we have written together. Integral dA is A total. Okay? And as we said in the formula we have written together, we said that x of the centroid times A total is equal to integral x dA. If we take x centroid, if we take A total to the other side, you get that x of the centroid is equal to integral x dA over A. Now here, if you want, you already did this integration. You can directly replace by A total. And as you can see, they replaced by the result, which is 3 over 4. You only have to do the integration of the upper side, which is integral x times elementary area. What is the elementary area? It's 1 minus x cubed dx. Okay? So here you have x minus x4. If you integrate, it's x squared over 2 minus x5 over 5. Okay? And if you replace by the boundaries, you get 3 over 10. Therefore, you can compute the value of x4.
دكتور بس ما فهمت كتير كيف عملنا هاي الانتجريشن x into 1 minus x cubed.
Okay. What is dA? What is the expression of dA? مش هي x times 1 minus x cubed? Yes or not? هيدي لقيناها أول شيء. The area of the elementary rectangle is dx times 1 minus x cubed. So here, when you want to replace, we said we should do integral x dA. This is x, and what is dA? dA is 1 minus x cubed dx. So this term represents, this term is dA. Okay? This is dA. مش نحن قلنا انه x bar is integral x dA over total area.
اوكي صح.
dA is 1 minus x cubed dx. Okay? Any question on this? Very good. Now, once you find f vertical and f horizontal, you can find the resultant force. Okay? Because look at this figure. You know that f vertical should pass by, is at 0.4 meter from A, because we got that x centered is 0.4. So you are sure that f vertical is along this line. Okay? And you know that f horizontal is at 0.333 meters from A, which is 1 over 3. So this is f horizontal. And you have found magnitudes of fh and f vertical. So now you can compute what? You can compute the magnitude of f resultant. Okay? If you find how to find f resultant, you say f resultant is radical fh squared plus fv squared. Okay? And once you find the magnitude, you can find the direction. You know why? Because if I do the rectangle of forces, so here, if I draw them, let's say this is f horizontal and this is f vertical, and you calculated f resultant. Okay? Now, you can find this angle. You can find the line of action of the force. How to find this angle? What should you do? Look, it's very simple. This is FH.
Inverse tangent.
Yes, and this is FV. Okay, so you can say that this angle, let's call it alpha. You can say that tangent alpha is equal to F vertical over F horizontal. You get the angle, okay? And you know the angle, and you know one point of application, because look, these two forces pass by, FH and FV pass by this point. This point is of coordinates 0.4 in x and 0.333. So you know the coordinates 0.4 and 0.333. Okay? If you know the coordinates of this point and you know the slope of your force, then you can find the equation of this line. Okay? Why we need to do this? Because they want us to find what is the point of application on the curve. Okay? To know the point of application on the curve, the point of application on the curve is equal to the intersection between this line and the curve. Okay? And already for the curve, you know that the equation is z equal to x cubed. Okay? And for this line, you calculated the slope, tangent alpha, and you know one point of application. So you can find the equation of a line, okay? Because you know that I can write that it's a line. So its equation is in the form y equals to, now because it's a negative slope here, so it's minus tangent alpha times x plus a certain constant, okay? How to find the constant? You replace by the coordinates of the point. So you say for y equal to 0.333, so I have x will be equal to 0.4. So if I replace, it's minus tangent alpha times 0.4, which is the value of x at this point, plus the constant. So from this equation, I deduce the constant. So the constant is equal, so my constant is equal to 0.333 plus tangent alpha times 0.4. So you found the equation of the line, and you know the equation of the curve. Okay, how to find the intersection point? You say when they meet together, they should have the same x, okay, and same y. So you say that minus tangent alpha x plus constant is equal to x cubed, because this will give you the point of contact. So solving this equation, we get x of contact point. Okay, and of course, when we get x, z of the contact point will be, we mean by contact point is the point of application of the resultant force. The point of application of the resultant force will have x given by this equation, and will have z equal to x cubed. Okay. Now they didn't solve it here in detail, but they just told you that if you find the point of intersection, you will find that it is at this distance. So they did the solution, but they didn't put it. And this is why I detailed for you how to do it. Okay? So they told you that if you do the calculation, you will obtain that the point of application is at 0.933 meters above A. Okay? Any question? Okay, so let us move to another problem. Let me check the chat one second. Okay.
دكتور فينا نكفي مرة جاي problem 9 لأن عندي exam أنا بعد شوي بدي أكون قبل.
Look, you know why? Because I should start because we still have only one session on this chapter. So please, I'm sorry, I will record this so you can view it later, and if you have any question, you will ask me, okay?
Okay.
Just I will start with this.
But doctor, there's only 2 minutes left and we have class
طب okay, خلاص, it's fine. Okay, we will stop here. Okay.
at 3.
Okay. So we will continue next time.
Thank you, doctor.
Welcome. Bye bye.